Hello everyone. Now we will be discussing about finding minimum and maximum using divide and conquer technique. So divide and conquer technique is a technique which is used to solve some set of problems. It will be dividing the array into two halves and it will find the sub-solutions. After that we will find out the solution for the final one by using the sub-solutions that we got. So here we have to find out the minimum and maximum from an array. So an array will be given, you have to find out the minimum element and maximum element in that array. So what we will be doing here is we are dividing the array into two halves and we will be using the recursive approach for finding the maximum and minimum elements. Then we will find out, so first half we will find out the maximum element, second half also we will find out the maximum element, and we will compare these two maximums. And which will be the maximum value, that will be the maximum among the all whole array. And same way we will find out minimum in the first half and minimum in the second half, and we will compare the minimum values, and which one value is the minimum, that will be your that will be the minimum value among the full array. So this is not by using the divide and conquer technique, this is by a straight max min. That means we are not using the, we are not dividing the array, we are just doing it. We are assigning max and minimum to the first value, that is the first element, that is a of 1, if the element is saved from 1 to n. And for I is equal to n, what we are doing is we are checking whether a of I is greater than the max value. If it is greater, means we are setting max is equal to a of I. Otherwise, if we are checking if a of I is less than min, then min is equal to a of I. This is the two conditions which we have to do, is this one. This will take a lot of time because a lot of comparisons is required in this. For that only we are using the divide and conquer technique. So in this divide and conquer technique, you can see here. See, we are checking whether if I is equal to j. If I is equal to j means there will be only one element. If there is only one element means max and min will be the same element. Correct? A of I. Otherwise, we are checking whether it is having two elements. If it is having two elements means what? I is equal to j minus 1. So if I is equal to j minus 1, we will check which one is greater or lesser. So if a of I is lesser than a of j, we will make maximum is what? A of j, and minimum is a of I. Otherwise what? Maximum is a of I and minimum is a of j. So this is a basic condition. There is one element, two element. Now we will come the others in this sense. If it is having more than two elements in that, what do you have to find out? We have to find out the mid value. Then we will apply the same max min in the left half and same max min in the right half. So I see here, you can see here, right? This one is what? 1 to mid and mid plus 1 to j, or I to mid and mid plus 1 to j. This is the thing we are finding out in this, and we will compare. So in these two values we will get maximum and minimum. So we will find out max is less than max 1 and min is greater than min 1. Which one will be maximum and which will be minimum? That will be the value. So this function will be completely invoked by the value I, j, max, comma min. That will be 1, comma n, comma x, comma y. So x is the maximum, y is a minimum, I and j are 1 and n. So 1 is the starting of the array and the position of the array, and j is the ending position of the array. So and if you do this one, you have to do the analysis part also. So always with the problems will be asked like explain the algorithm and analyze it, analyze the time efficiency. So you have to find out the time efficiency in this. See, when you check in this, it has two recursive calls which is divided into by 2. So you can write here t of n by 2 plus t of n by 2, and these two comparisons are also there. That's what it is written, plus 2. So what it is, t of n by 2 plus t of n by 2 plus 2. Now t of n by 2 plus t of n by 2, you can write it as 2t of n by 2. Yes, plus 2. Now, and we got right to see how if two elements are there, how many comparisons is required? You need only one comparison. So we can write it here, t of 2 is equal to 1. That means time required to compare two elements is 1 comparison. Now when we substitute this one, you can do the substitution method. That is, you will find out what is t of n by 2. What is t of n by 2? 2t of n by 2 power 2 plus 2. So that value only we are substituting it here. So when you see, you will be able to understand this one. See, t of n is equal to 2t of n by 2 plus 2, and you will first substitute the value of t of n by 2. So what is t of n by 2? T of n by 2 is equal to 2t of n by 2 square plus 2. That's what 2 t of n by 2 square plus 2. This one you will substitute in the first equation. You will get here 2 into 2t of n by 2 square plus 2 plus 2. So you can write it like this. Now in the same way, you can write in the general form. How you can write this general form? See, 2 power I and t of n by 2 power I plus 2 power I plus 2 power I minus 1 plus up to 2. Now you can see, you will be knowing that only t of 2. You know only t of 2 is equal to 1. This is a basic condition we know. So from here, how to get t of 2? You will be getting when n is equal to 2 power, n by 2 power I is equal to 2. That means n is equal to what? 2 power I plus 1. Now when you substitute this one here, 2 power I t of 2 plus 2 power I up to n. Okay. Now in this, again 2 power I into 1. What is with this one? 1 plus 2 power I plus 2 power I minus 1 up to plus 2. Now 2 power I am taking it outside, and since here you can see what is 2 power I plus 2 power I minus 1 up to 2 power 0, that is a GP, that is geometric progression. You can substitute the values here. Okay, that is a of n r minus a into r minus 1 by r minus 1. So that is the thing that you have written here. Now when you do this one, you can write here 2 power I plus 1 plus 2 power I minus 2. This one you are substituting this. I mean 2 into 2 power I minus 2. So this is the thing we are getting. So at the end you will be getting here 3n by 2 minus 2, which can be written as 3n. So this is the way you have to solve the binary search algorithm. So in this, two things you have to find out. One is write the algorithm for the binary search by using divide and conquer. So divide and conquer works like this. We will be dividing this array elements into two halves, and we will be finding out the maximum and minimum elements in both the half, and we will compare this maximum and minimum in the both the halves. We will compare and we will find out the final maximum and minimum. So irrespective of comparing all the elements, what we are doing is we are dividing into two halves. That is called the divide and conquer. Divide first, then conquer. That means divide first and find the solution. And one more thing we have to find out in this, that is the analysis part. So you have to find out the time efficiency in this. So in order to write a time efficiency, you need, since it is recursive algorithm, you have to write the recurrence relation for this. That is the recurrence relation that is being written here. T of n is equal to 2 t of n by 2 plus 2, which is equal to, at the end when you are doing substitution method, at the end you will get 3n by 2. So you can see here 3n by 2 minus 3n by 2 minus 2. So this is the way you have to do this problem. Hope you understood this one. This is another very important that is being asked from the module 2. Hope you understood it. That's all for today. Thank you.